Hello everyone, this is Xiwen.
Hello everyone, this is Shijun.
Today we are gonna present our project about offline reinforcement learning for recommender system. Before technical details, we ask the question, what is recommender systems? Recommender systems are widely used in our daily life. For example, video streaming platforms like YouTube and Netflix, e-commerce like Amazon. The goal of recommender systems is to enhance the user experience by generating personalized recommendations. So the recommender systems must be interactive and capable of long-term planning. Reinforcement learning-based methods have been used for designing recommender systems. However, there are some key limitations with these conventional RL solutions. First is the complexity, with both the model architecture and learning process, which requires significant amount of computation and storage. Then end-to-end training is also less explored, but it's really important for real-world applications. In addition, traditional methods use important sampling-based off-policy correction, which brings limitations like multiple changing policies, large scale of historical data, and so on. To overcome these limitations, we would like to think the problem from another perspective, the sequential model. The working paradigm of the sequential models is to fit all the previous states, actions, rewards, along with current state to the model, and then expect the model to output the prediction for next action to take. As a result, we ask ourselves, can we modify the sequential model approach to predict an action that has a higher cumulative reward, not just the one-step reward? If the answer is yes, the purpose of reinforcement learning can be achieved with a supervised sequential learning framework. Motivated by this, we propose our approach, the return-conditioned RL. On the training stage, because there exists a typical offline data sequence which includes the state, the action taken by the agent, and the feedback from environment at every time step. We first calculate the cumulative reward from the current time step, and then relabel the offline data by replacing the one-step reward with these cumulative rewards. Then the model could be trained in a supervised paradigm. The target of training is to maximize the likelihood of taking the ground truth action given the current state and desired reward. Then on the inference stage, we first specify the goal as an average return on the offline data multiplied by a hyperparameter. We also specify an initial state as a conditional information. Then the RL model generates the sequence step by step by predicting actions towards that goal. More details of the training are shown in the pseudocode.
And this is an example to explain the mechanism of return conditional reinforcement learning in recombinant systems. As we can see, we assume that there are three sequences as offline data to train the RLs. P, C, and G there denotes the popular, classic, and jazz music. And each sequence means that the user has listened to this music sequentially during a recommendation session until they quit the system. So the question is, after the training on this sequential data, what item will be recommended for the user whose behavior sequence is P and P? So for a conventional static recommender system, it will recommend the popular music because it doesn't consider any sequential information, and P is the most historically popular item on average. For a sequential recommender system, it will randomly recommend P, C, or G because more of them will listen after P and P, demonstrated by the offline data. In contrast, a recommender system based on return conditional reinforcement learning will recommend different items given different returns. For example, if we hope the user listen to three more music after P and P, we should definitely recommend classic music to him. In this case, although the user has listened to P, G, and C after P and P, his current preferred item should be classical music instead of popular music or jazz music. because he chose to quit the system after listening to P and J, which exactly indicates that he's not satisfied with the current recommendation and felt bored with it. In contrast, he still stayed in the system and listened to more music after listening to the classic music, and only return conditional reinforcement learning can model this mechanism based on the returns, which are kind of a description of the future. Uh, we conduct our experiments on a public dataset. This dataset is collected from a real-world e-business platform. For the metrics, we use the hit ratio and NDCG. Both of them are widely used metrics for evaluating the accuracy of models' prediction on users' preference. And also, we include 6 baselines for comparison. These baselines are classic recommender system models in previous research, and they are combined with different model architectures and optimizing algorithms. So this is the results for the comparison of the performance. And the second table is the results for the comparison of the time and the storage complexity. As we can see, the results demonstrated that the proposed method can significantly improve the model's performance compared to these baselines. Also, it benefits from a smaller model size and faster training speed. This advantage positions our model as a promising solution for real-world recommender systems, particularly for those with a large user and item pool. So in conclusion, in this project, we hope to reduce the model architecture and the optimizing complexity in previous conventional reinforcement learning methods. And we hope to design a new model structure to pursue the long-term cumulative reward in recommender system by building up a simple sequential supervised learning framework. And with the help of return conditional reinforcement learning, we design our framework and complete the experiments. The result shows that our proposed method has the potential to be applied in real-world large-scale recommender system. Thank you.